Hello guys, let's continue how to find the relative extrema using the second derivative test. But before I solve the exercise in page 6 here, how to use the second derivative test? Let f be a function such that the first derivative equal what? 0. Be careful. He didn't talk about the values of x at which the first derivative does not exist. Only the zeros of the first derivative. And the second derivative of f exists on an open interval containing c. If we replace by the values of x at which the first derivative equals 0 only, in the second derivative and the value greater than 2, it means positive, we have a relative minimum. Why? Look here. If we have a second derivative greater than 0, it means it is what? Concave upward. Concave what? Upward. If it concave at upward, so in the function has minimum value at this value of x equals c. Here, if the second derivative less than 0, it means concave what? Downward. It means it has the curve of the function has what? Relative maximum. If the second derivative equals 0 at this value of x, it means the test fails and we have to use the first derivative test as you learned it in the topic increasing and decreasing of the function and how to use the first derivative test. Okay, here. Let's continue the solution. Here question, I'll solve question, the first question in page 6 and the third question in page 6. The others one, I think it's so trivial, it will be homework. Now, let's show you how to solve number, I think number 2, it will be like number 1. No, okay, I'll solve. Let's begin here. What is the first step? I have to find the first derivative. Then find the zeros at this first derivative. It will be 6 minus 2x. Then find the zeros of where the values of x, the first derivative equals 0, implies 6 minus 2x equal 0, implies x equal 3. Okay, then find the second derivative. Second derivative, it will be negative 2. It is less than 0 for all x in all domain. Okay, so it means if second derivative at 3 equal negative 2, less than 0. Since it is negative 2 for all x, it will be negative 2 at x equals 3. In this case, concave upward or downward? Concave downward. Okay, so relative maximum at what? At the value x equals 3 and the f3 which we replace in the original function here, replace in the original function, it will be 9. So this function has a relative maximum at the point 3 and 9. It's so easy. Find only the zeros of the first derivative, substitute in the second derivative. If the value negative, it means we have a relative maximum at this value of x, and if x at this values of x where the first derivative equals 0 does not exist. I hope you understand. Now I'll solve this exercise. It's so trivial. Please focus with me. The first step, I have to know what is the domain. X not equal 1. Because the function undefined at the zeros of denominator. Okay, first step here, the first derivative, it will be find the derivative. I'll use the quotient rule. Okay, square the denominator, begin with the denominator, multiply the derivative of numerator, which is 1, minus the numerator multiply the derivative of denominator, which is also 1. So it will be x minus 1 minus x over x minus 1 all to power 2. This one cancel. It will be negative 1 over x minus 1 all to power 2. Okay? Miss, here, f prime x not equal 0. Why? Because the value of numerator, the first derivative equals 0 if the numerator equal 0. Since the numerator not equal 0, in numerator here, not equal 0. In this case, the first derivative not equal 0. For all x. خلاص? For all x. Since in here not equal 0, okay, I don't have any value. I substitute in the second derivative. In this case, there is no, because at the values of the first x at which the first derivative equals zeros, we have a relative extrema. So there is no relative extrema. I have a relative extrema by using the second derivative test by substituting by the value of the x at which the first derivative equals 0 in the second derivative. But already I don't have, so I don't have extrema. I think you understand. Well, we don't have relative extrema, okay, on this domain. We don't have a relative extrema. Because as you know, okay. Hello guys, let's continue. Okay, this question, which is, what is the part of this one? I'm sorry. This part, yes, we solved this question. So we don't for the third, I think the third, this one, the third one, question in page